So fabulous, David Ashford. It's a pleasure to finally see you and to have a conversation about space planes and wherever this is going to take us. Like you've got a history in the industry, but I wanted to give you an opportunity just to let us know what your work has been, like what Bristol Spaceplanes is, and how you've ended up here.
Right. Well, I did aero engineering at Imperial College, then some rocket motor combustion instability postgraduate research in the States. Then I joined the Hawke City Advanced Projects Group in '61, working on their working in their spaceplane design team. And at the time, satellites were launched using converted ballistic missiles. Only fired them once. Quite clear even then it was never going to become economical. So without exaggeration, most big aircraft companies in Europe and the States had quite big teams, mainly staffed by airplane designers, looking at airplanes that fly to and from orbit to replace these ballistic missiles. And the consensus was it was the obvious thing to do, the obvious next step, just about feasible with the technology of the day. And that given time, it would revolutionize spaceflight by replacing a missile-based transportation system with an airplane-based transportation. You don't have to be a rocket scientist to appreciate that an airplane is a better way of carrying people or things than a ballistic missile. Anyway, to cut a long story short, these had never been built. They weren't developed at the time, largely because the money for high-tech prestige projects in the States went into Project Apollo, the race to the moon against the Soviets. And in Europe, the same money went into Concorde. So these spaceplane design teams were allowed to disband, and the lobby in favor of an aviation approach and the knowledge needed for an aviation approach gradually fizzled out. And I maintain that these 1960s designs, they've never been surpassed, but they've generally been forgotten and overlooked, except by me. As far as I know, I'm the only person active who took part in the first round of studies, when the creative thinking was done. I went to the conferences, read the papers, had my first paper published in the Aeronautical Journal in 1965. I'm the only guy that I know of from that era who's still active in the field. And what we're saying, and nobody else is saying it, is that the technology, all the technologies that you need dead, or that would have been difficult in the 1960s, have since been developed on other airplanes. So what would have been a difficult and expensive project to build would now be straightforward. I think of airplanes like the Saunders Roe 53 rocket fighter, the X-15, Lockheed NF-104, Concorde, Spaceship One, Spaceship Two. So all the technologies, so our design, the orbital design, Space Cab, uses only proven technology.
Right. So, like, you run a company called Bristol Spaceplanes down in Bristol, obviously, and I've seen a lot. I've read all of your books actually, and about the designs that you put forwards as a result of your experience, right? But it seems the industries and the UK have gone in a different direction, as you said. Like, it's gone towards Concorde, and the engineering now for that has kind of been lost. You've got the Saturn V development, and the engineering now for that has kind of been lost. It's kind of it's having a bit of a redux with the Space Launch System at the minute. So they're kind of redeveloping that whole knowledge base again. But I guess like my question kind of comes to Starship and how like, they've kind of worked towards a model of landing and reusing the entire rocket. Like, how does that kind of stack up against using space planes? Because like in your book, you talk about the cost reduction of using space planes because it is a completely reusable system. It becomes an aircraft model. You can reduce the cost, I think, 1,000-fold from completely expendable. So how does Starship stack up to that?
Yeah, well, I reckon Starship, it stands a very good chance of being a game changer. It is fully reusable and it's very large. But it's vertical takeoff and landing.
Mm-hmm.
You land on a rocket pad with an autopilot, under the control of an autopilot. For carrying people, I think you want something more like an aeroplane, horizontal takeoff and landing, wings and pilots. But as I see it, they'd be complementary to what you really want. For low-cost access to space is what's long been called the low-cost orbital infrastructure.
Okay.
Which consists of space stations of modular construction, so you can use them for different purposes. You need a heavy lift vehicle for launching these space stations, preferably reusable. Mm-hmm. So Starship would be ideal for that. Having got it up there, you want some means of day-to-day supplies, resupplying crew and supplies. And the analogies with the offshore oil industry, you have big platforms, big drilling platforms, more or less permanently in place, like a space station, towed into position by an ocean-going tug. That's your Starship. And with everyday supplies, helicopters or small boats, well, that's where Space Cab comes in. It's a small area. It's got a payload of less than a ton, but you make several. You'd be capable of making several flights a day.
So the Space Cab design is two-stage. So you have like a shuttle style space plane that has a smaller shuttle on the top that I assume kind of follows the same model as what Virgin Galactic aiming for, where there is some kind of carrier aircraft that gets it up to a specific altitude before it drops or disconnects from the main body before carrying upwards towards low Earth orbit. So I guess like with Virgin Galactic picking that up, you must be quite happy that this is being developed. But maybe what do you see wrong about maybe the route that they're pursuing versus what you're advocating for?
Well, Virgin Galactic is suborbital.
Right, of course, yeah.
It's up and down to space height. You get 2 or 3 minutes in space. To do that, you need to get in an airplane, get up to Mach, just over Mach, 3 times the speed of sound, on a very steep climb, maybe 70 degrees angle of climb. And from Mach 3, it'll coast unpowered up to space and back. Technically, that's a whole lot easier than orbital, where you need Mach 25 in horizontal trajectory. And there are features about the Virgin project that are not really appropriate for an orbital transport. They've got this, they've got a hybrid rocket engine, which is fine for suborbital, except it hasn't been properly developed. It's an immature technology. It's never been used on a large scale. And they've got this shuttlecock re-entry system, which works fine from suborbital. But
well, allegedly,
not suitable for orbital.
I think they've had some issues with stability coming back in because of the lack of air resistance. It's kind of they've ended up like going a little bit too far over on their way back down. But I remember listening to Elon Musk talk about his like VTOL jet at one point. It was completely irrelevant from the stuff he's doing with space. But he was talking about the atmosphere being the primary issue when it comes to getting up into orbit, because if you can get above a large portion of the atmosphere, the amount of fuel that you need, the size of the craft that you need to get to orbit reduces drastically as well. So is that kind of the model that you're pursuing with this space cab, is that you can get above a certain level and then carry on?
Well, that applies to any satellite launch vehicle. You've got to get clear of the atmosphere.
Yeah.
On a steep climb, then turn over and accelerate horizontally to satellite speed. So the Virgin project, but there's a slight, the difference in vertical takeoff and horizontal takeoff is quite marginal in terms of overall performance. But any satellite launch vehicle has to do the same thing. Get clear of the atmosphere on a very near vertical climb, then turn over to horizontal acceleration.
Right, because this is kind of because I mean, so with Supernova Labs, we've spoken in the past about this before. I've been looking into SSTO space planes for a very long time now. Kind of reached the point of realizing that you would kind of need something on the order of the size of Starship, or what Skylon has designed for their system. So ultimately, what you're saying, it kind of comes down to, it doesn't really, like the difference between horizontal and vertical launch, like, isn't really that different. The only real benefit to space planes and SSTO space planes or two-stage space planes is the fact that there is some escape route if there are problems in flight, that it can just turn into a glider or a plane.
Yeah, it's probably the key issue, seems to me, is certification, is safety certification for carrying passengers. The market leader for orbital transport will be the first launch vehicle of any kind that gets certification for carrying passengers. Because with reusable vehicles, we're all agreed that's essential. The costs are going to come down and the launch rate's going to go up a lot. A lot more people are going to go to space, either as tourists or scientists or astronauts. And with that large number going up, you need much better safety. And the safest flying machines yet invented are airliners.
True.
Our design logic is to make the thing as much like an airliner as possible.
Right, because if an airline fails, right, they are designed to a standard where they can, even if you lose every engine, there is still some degree of tolerance in there for it becoming a glider and able to land safely.
Yeah, and there's the market leaders at the moment are Richard Branson, Virgin Galactic, Jeff Bezos with his New Shepard, and Elon Musk with Starship. They've all got to get their landings right first time.
Yeah, absolutely. And this is the biggest issue,
the
right?
Virgin thing lands like a glider. There isn't any power. There isn't any thrust for going around an aborted landing. So if you're coming into land and a cow runs across the runway, or there's a dust storm or something, you might get away with it.
Right, so there's no
desert, Mojave Desert. The Jeff Bezos New Shepard land, the passenger capsule separates off from the booster and lands by parachute, which you can make that safe, but I think it'd be a lot more effort. It's a lot easier to make an airplane safe. And Elon Musk lands vertically on a rocket pad, which is a brilliant. He's proved that technology on Falcon.
Yeah, I mean,
it's a brilliant technical achievement.
Genuinely amazing. Like,
but again, I think it'll take a lot longer to get that to airplane safety. I mean, airplanes are designed to have a failure rate, a serious an accident-causing failure rate, fatal accident causing of but 1 in 10 million.
Wow, yeah. And rockets come nowhere near that.
A long time before vertical landing by rocket gets to that level of safety.
Interesting. So I guess the only real like flight proven analogy to this is the shuttle kind of Buran dichotomy, right? And they decided to scrap a lot of the fully reusable features due to like wanting cost savings. That, I mean, ultimately ended up causing a lot of the failures, but they took away powered flight as well. So like the whole model for proving out a craft that can land on its own steam, but has the capability, even on the landing, even on the runway, to be able to abort that landing to go for a second pass, has never really been done.
No.
Interesting. Okay. So where do you think the UK is in terms of its space industry currently versus maybe about 5 years ago? And are we best placed to try this out?
Well, there's been a lot of government support for space over the last 5 years, maybe even longer than that. We're very well placed. We've got access to all the technology. We've got a culture of innovation and a world-class aerospace industry.
Definitely.
It's a disadvantage and an advantage. The disadvantage, we've got no experience, no recent experience in launch vehicles of any kind, except very small ones, which haven't gone into service yet. They're still being developed for launching small satellites. But it's a long time ago since Blue Streak and Black Arrow were going into space. Which is an advantage and a disadvantage. It's a disadvantage in that there are bits of technology that we're a bit rusty on. The advantage is we're not locked into the missile mindset. This may sound crazy. You might think that an activity like space transportation would be, the big decisions, policy decisions would be made rationally. There's no reason why they shouldn't be.
They're
not. I can assure you they're not.
Evidence that's quite clear at the minute, though.
It's been so long. It's 50 years since anybody looked properly at fully reusable space planes. And somebody like me comes along and says, "Hey, you can make this using only proven technology." You've got an incredible credibility problem. People say, I've given dozens of presentations, and they all end up with questions like, well, if it's as good as NASA says, why aren't they doing it? If it's as good as you say, why aren't NASA doing it? Or it's inconceivable. You're the only person to have got the answer to low-cost space transportation. Well, that's an easier one to answer because I'm the only guy left over from this 1960s round of studies. So I've got one unique selling point already. So, but you've got a big credit, and you need a big corporation to find the money to do this.
Yeah, IBA have taken on reaction engines pre-cooled now.
That's right. And big corporations are very conservative. They've got to be. They've got to think about the shareholders.
That's true. Bottom line, isn't it?
So the biggest obstacle I'm faced with is mindset.
Now you see, I've spoken to Tori Bruno about this. Like he's the CEO of ULA. For those that don't know,
CEO what?
Of United Launch Alliance.
Oh yes,
over in the States, because his background is he worked on VentureStar and all of the Aerospace work for the space plane they were developing. And the only reason it got shut down was because they were having problems with the composite tanks and microfractures inside of the tanks. There was never anything wrong with the engine design. There was never anything wrong with other than the material choices for the plane design, it was ready to go. And I think I'm kind of curious about Sierra Nevada, whether they're kind of like a shell company underneath the ULA, like it's kind of not confirmed in public space, but it seems to be following their kind of model. But I guess this is the biggest problem I've faced as well, talking about this as well. Like again, coming back to this credibility problem, is that it's almost like people gave up on space planes after Challenger, and it was like, well, rockets are safe. We know rockets are safe. We've done it for so long. Now we're in a position where this model's been around for nearly 70 years now to develop these kind of space planes, And it feels like such a massive wasted resource. I don't know what, like, I guess this is kind of, it comes back to why I wanted to speak to you, David, as well, because like I've seen the work that Bristol Spaceplanes has done, and it's like unbelievable that it's not been picked up by either the UK Space Agency or the British government or BAE or Reaction Engines. And I guess I wanted to ask why, why do you think, in your view, has that not happened?
Mindset.
But like, what would be the intervention you would make in that mindset?
Well, I've given presentations to all of them. Not recently. So if I tried again now, space is much more on the agenda than it used to be. Space tourism.
100%.
The big market for space planes is space tourism, in our opinion. And that's now becoming, because of the efforts of Richard Branson, Elon Musk, Elon Musk and Jeff Bezos, that the market, the existence of a substantial market is now beyond sensible doubt, which is useful. No, I agree with you. I'll make a confession. I'm a pretty lousy marketeer. Well, I think that's the reason. That's the reason why. One reason that contributes to the fact that they're not taking Bristol Spaceplanes' work seriously.
Well, I'll tell you, you make up for it in terms of engineering excellence, because I look at the work that you're doing as like kind of like my baseline inspiration for everything I'm doing with the SSTO work and all my design, because I can't, I mean, we've spoken in the past about doing things in terms of crowdsourcing and doing things as like part of a group, and you've talked about co-located teams, and I definitely see the value in that now, because the speed at which I'm able to operate pulling together people in a crowd is far slower than I think you would be able to work if you had a massive team. Well, if you had a team that you can work together on designs with.
Yeah. Yes, I agree. I mean, I haven't given up. I'm still talking to these people.
I'm glad to hear that.
Now, what we'd like to do is form a joint venture with one of these companies you mentioned, an established aerospace company, preferably UK. And we provide a lot of the intellectual property. The basic designs would be based on our designs, and they would provide the resources.
Interesting. So I had a chat with BAE at one of the conferences, the space conferences last year. I was talking to them about Tempest, because I've been talking about Tempest and like having some either suborbital capability or orbital capability for that craft, because for the amount of money that people have pumped into the F-35, I think you could easily have an entire suite of orbital class space planes for that.
Oh yeah.
They mentioned in passing that the pre-cooler work for reaction engines may be integrated into the F-35 to allow it to do more high altitude work. So there may be routes in, and I don't think the UK government. I think the UK government has started sniffing around this kind of thing. If this video landed on somebody's desk within the UK Space Agency, or in BAE systems, like what would you say is the first step towards getting to the vision of the spaceplane future you want?
Right. Can you see that?
Yeah, I can. Yeah,
It's a small model. That's our ascender design. It's 2 seats. It's like a quarter-scale Concorde.
Okay.
So it's 21 feet wingspan instead of 84 feet. Size of a small jet fighter. Just 2 seats.
Oh, that's cool. Jet
engines up to nearly Mark II. Rocket engine, steep climb rocket engine up to just over Mark III. Zoom. Go up to space. Only suborbital. but it would get the show on the road. It would start to mature the engine technology, and it'd be much enlarge this to Concorde size, and you could carry 20 people on suborbital flights and work out the economics. Eventually, when you've got long life rocket engines and each aeroplane is capable of several flights a day, so when the design's mature, the cost per seat on a suborbital flight is nominally £5,000.
Which is kind of on the order of the inflation-adjusted price of Concorde tickets back in the day, right?
Yeah. We reckon, well, there's been quite a lot of market research on space tourism. And at a price of £5,000, several million people a year would want to go to space on suborbital flights. Say 1% of the global population once in a lifetime. It works out as at a few million. You needed a fleet size of at least 20 space planes. Now, there's no other use of space, projected use of space that's been studied seriously. We need a fleet size of 20 vehicles. So you have a far larger fleet size than anything else. And lower cost, £5,000. So that would bring in aeroplane transportation to space, only suborbital. But that's the breakthrough. And for some reason, people find this very difficult to comment. I think what's happened, as I say, you might think that space policy will be derived rationally, but it isn't. Mm-hmm. When the 1960s space planes were abandoned, given up, and the teams disbanded, you've got the beginnings of a cultural divide between space transportation and air transportation, and that's been allowed to grow into a chasm. There are very few rocket designers, launcher designers, who understand airliners. There really are very few, and the very few airline people understand space launch.
But there was quite a big thing back in the 60s where, I mean, there's a YouTube channel called Dark Skies that I follow, and it goes into quite a lot of detail about the British Aircraft Corporation, like what all the different designs for like jets that were coming out after the Second World War, and how the UK and Great Britain were like we were producing the absolute best aircraft and jet engine technology in the world at that time. But then all of a sudden, it just seemed to, like some kind of switch going off. All of the engines were destroyed. All of the test articles were destroyed. Like we kind of just, I don't know whether we either like lost our confidence in terms of producing for that sphere, or whether there was some kind of like influence from outside that was kind of, okay, we'll take that technology and develop it in our country instead. But I guess that's kind of why I've been kind of beating the drum on this, is that like, well, how do we get back to that point and kind of make good on the fact that we were the only country in the world that developed an orbital capability and then scrapped it the next day?
Yeah, well, I think the answer is this. This would restore or go a long way to bring back an autonomous UK aeroplane design capability. When did somebody in the UK last design an aeroplane? A high performance. Tempest is going on at the moment. Mm. The last one was the Eurofighter, the Typhoon.
Yeah.
But there's very few. When I joined the aircraft industry in 1961, we were roughly, before 90s, there were roughly 10 interesting prototypes per year. That went down to one every 10 years. But part of the reason for that, I'd say, is that in World War II, performance was everything. We had to win the war, regardless.
It's massive technology pull, isn't it?
after the war, what you needed was reliability and economy. But the mindset of government and the aircraft industry in the war was paid for by the government. You didn't need very strong commercial management. Whereas in the States, the airlines have always been much more separate from government than they have here. And the aircraft industry has always been more independent, self-supporting than it has been here. So the quality of management in the British aircraft industry was very poor. So the most post-war airliners were failures. Or the Viscount was a brilliant success, but the Comet failed. It was too ambitious for technology today. The Britannia, they only made 80 of them because it was very badly delayed by technical problems and by squabbling between government and industry.
Yeah.
You can name a whole lot of airplanes that failed. And but if you look at the British aircraft industry now, it's good. It's profitable. So profit has given way to prestige, has given way to profit, which is probably a good thing. I mean, we've got a very good aircraft industry, and I don't think there'll ever be another big airplane, commercial airplane, where the government puts in all the money like it did with Concorde. Any future project will have to have a lot of industry investment. 50-50 government industry, which is a very good thing.
There were 2 points on that. Like, I remember when I left university, I downloaded the final throes of the library account. I was downloading as many papers as I could while I still had access. And I downloaded an industry report from some aerospace, I don't know, like a think tank. And they were outlining, well, what are the key threats and opportunities for the UK aerospace industry? One of the biggest threats were startups, because there was such a large monopoly inside of the aerospace industry in the UK. Because if you imagine with monopoly, you end up with all the projects going towards one party. That information isn't really shared inside of industry, so you do end up losing those capabilities in industry at large because they're kind of held within these silos. So startups are the best place to kind of break that back open.
Well, that's what we come in.
Yeah, exactly. Well, this is the thing I forgot my second point.
We're looking for investment. We're looking for industrial partners. We need 100K to finish the design. There's a few things not finalized. We need 1 million, these are very round numbers, to build a full-scale engineering mock-up. The representative light alloy structure and the real engines. The real engines are available. Well, the rocket engine is a reverse-engineered 1960s UK rocket engine. They exist in museums, but we know it works. You go to your museum, measure the thing, and you know you've got something that works. And with a full-scale mock-up that looks impressive, you've got something to show people. £1 million is well within the scope of a startup. The next thing is to make a low-speed flying prototype. Again, well within the scope of a startup. It would have the definitive airframe and jet engine, but wouldn't have an early development rocket engine, not the definitive one. You wouldn't have the reaction controls or the thermal protection or the cockpit pressurization. But at least you get something flying.
Right.
You're starting the dialogue on certification with the CAA.
Yeah.
You're making progress. Then you fit the definitive rocket engine, reaction controls, cockpit pressurization, a little bit of thermal protection, and that's a sender. And we, as a startup, we could do that. But I'd much rather do it as a joint venture with a big company. So they've got the premises and the production workforce.
We share the risk as well, right?
We've got a core team of engineers that have studied this at the sender. But it could be a joint team, engineering team between the company we do a joint venture with And there's a very strong business case for an aerospace company to do that. The return on the business case is incredible. It's a very good return on investment. The trouble is to get them to take it seriously, or the difficulty is to get them to take it seriously. And
I remember my second point now.
That's what I'm working on at the moment.
Yeah, no, I remember my second point now, because you were talking about how industry is kind of they've taken prestige and given way to profit, and I personally found difficulty with the way that the UK funds projects and seems to judge viability for projects on the basis of a venture capital and angel investment model that they've kind of inherited from the city, instead of it being, well, I guess I can't speak for how it used to be in the past, but my assumption is it was very much technology pull. These were like state capabilities that we needed. So money wasn't really, it was how much do you need to make this happen, rather than how much am I going to make back from this in terms of profit and bottom line. I don't know, like maybe you could speak to how it used to be versus how it is now.
No, I think you're right. Profit is now much more important on the, you've got to tick the profit box before you, if you can't tick the profit boxes, you forget all the other boxes that don't count. But reaction engines started off as a startup. And I think the story I've been told, I don't know how true it is, but Alan Bond, who started reaction engines, gave a presentation to a space meeting on his engine. And somebody came up to him afterwards and said, "Could you use £1 million?" So they got some private funding, and on the back of which they've got significant government funding and investment from BAE Systems. So it can be done.
Yeah, it can be done. It's definitely been a big movement recently, because I remember even 5 years ago, reaction engines were talking about having this pre-cooler. They were trying to build this demo rig to test it, but I think George Osborne threw a bit of money to them. It wasn't really a lot to get them started before BAE stepped in and like, okay, well, now we see the viability of this, we're going to start moving forwards with it. So there was so much they had to do just to get to that point in terms of building physical hardware. I guess that is maybe the breakdown I see with how we develop things here in the UK versus how it's developed elsewhere, because funding seems to be a lot more forthcoming for projects on the merit of whether it's going to be viable in the future anyway, instead of needing to prove above and beyond.
No, I think that's right. If I'd been working in America, I think this would have got off the ground years ago. It's much easier. There are far more people in America who combine extreme wealth with vision. I would say it's a personal opinion, but history will indicate that the most important person alive now, in terms of impact on history, is Elon Musk.
Easily, yeah, easily.
As an individual, and there are teams, I can't see anybody who will match him. And that the culture in America supports people like him. At a quite early stage in his development of his rocket launchers, he got NASA backing. There's no rivalry, or less rivalry, between the government agencies and private industry in the States than there is here. I mean, for many years, the British National Space Centre wouldn't talk to me.
Oh, really? Why do you think that is?
Well, it wasn't government policy.
I see. Yeah.
Well, they would talk to me, and I did get a contract off them, but a very small one. And they did introduce me to the European Space Agency.
Right, because
My
there's a
first,
tension, right? There's a
sorry?
tension between like the UK Space Agency wanting to like strike out on its own and become this like forward-thinking space power in the future, but we're also kind of tethered to the well, they're not even. I don't think that's a very good way of describing it, but like we're beholden to commitments at ESA for good reason because like they're able to allocate the resources to enable exploration and technology development across the entirety of the EU, which has been massively beneficial. So how does the UK square those two obligations almost?
Yeah, well, I don't think Brexit's got much to do with it because we are
Yeah,
the UK is a member of the European Space Agency,
yeah, and will continue to be so hopefully.
fully paid up. I don't think it's made any, it may have done, but I don't think it's made any difference to the UK getting its share of the ESA budget. It may have done marginally. I'm not sure. But it would have been, this project would have been easier to get the money for in America, but it's far easier to get it here in England or Britain than in any other European country.
Yeah, so like I guess maybe where the breakdown has been is that the UK Space Agency has primarily been there to administrate the ESA funding that has been coming back in, rather than what NASA has, which is this enormous pedigree of like technology, of infrastructure, like physical assets, engineers, uh, just a knowledge base from this Saturn V and the Moon program that they're able to do technology transfers out to industry, and that's like it's like very well established, that model. Whereas I don't know whether the UK Space Agency is struggling maybe to do the same here because we haven't done that legwork first. We don't have that pedigree to lean on yet.
Well, I think the Space Agency is putting a lot of effort into space launch.
Yeah, that's
They're
changed. It's good.
subsidizing the development of spaceports.
Which is
They're putting a
amazing.
bit of money into two or three, you probably know them, UK companies developing launches, small ones, dedicated for small satellites, which is a burgeoning market in Britain, is among the world leaders in small satellite development.
Yes,
so
yeah,
there are those
Skyrora and Orbex, I think, are the two that
Sorry?
come to mind. The Skyrora and Orbex are the two that come to mind immediately.
Yeah, that's right. Mind you, our space cab will make them both obsolete. Because
that's fighting talk.
It's fully reusable, and it's an airplane. And I don't know of any expendable transportation system that can compete with the reusable one.
Well, here's the question as well. I mean, since SpaceX have landed Falcon 9 boosters, I don't understand how any technological development after that point can justify expendable launches, other than the fact that it's proven technology. It's maybe cheaper to develop, but more expensive in the long haul.
Yeah, no, I agree with you.
Yeah, interesting. So I guess it comes back to like an initial like stage. Where do we go from here? Because I know you've put forward applications for money for this Formula Space style spaceplane design competition. I don't know whether you want to talk about that.
So which one?
Like this spaceplane design competition for universities you were talking about.
No.
Like you were going to, like, I was talking about like a model version of it that students could get involved with or something.
I hadn't mentioned that in this conversation.
No, of course not. Like, in our prior conversations.
I don't know any spaceplane design competition.
Okay. So I guess maybe maybe a better question to ask would be like, well, what are the things that I can do to help you?
Well, what I want more than anything else is introductions to senior management in the aircraft industry.
Okay. Well, I will do my best to facilitate that. And maybe there will be people that see this that want to help you out as well, that can help position Bristol Spaceplanes like that.
Yes, as I say, there are about 5 or 6 big companies in the UK that could do this project quite easily as a joint venture. And I've given presentations to all of them, but not recently. And I think in those years since I last presented to them, we've got a lot more persuasive. We're much better at presenting our case.
Yeah, there's a groundswell as well, like around.
And the groundswell in the background is much more, there's much less resistance to the sort of thing we're saying. So the next time I have a meeting with a big aircraft company, the chance I think we'll win. I think it'll lead to something.
Brilliant. I really value that attitude, David, and I'm glad that you still have that. I guess, like, for people of my generation, like, we're coming at the space industry kind of fresh, because I don't know whether, like, because there's been this decline in space technology over the past, like, few decades, from being able to land on the moon, kind of retreating back to low Earth orbit. Like, what do you think that we need to learn as, like, the younger generation, starting up this whole NewSpace kind of industry now? Like, what are we missing, and what do we need to learn from that period?
Yeah, that's a good question. I mean, this may sound trivial, but you want the best of the old and the best of the new in any aspect of human activity, which sounds trite and obvious, but it means if you set that as your target, you've got to think, what is the best of the old and what is the best of the new? I mean, most people, including me on other subjects, will instinctively favor the old, and other people will instinctively favor the new. There's a strong built-in bias into the way we think. So you've got to get over that and decide rationally what is the best way ahead for space. And I think we've done that. We've got a very simple design logic which only we are pushing, and it goes as follows. To get costs down, you need full reusability and high traffic levels. There's only, the number of satellite launches a year is only just over 100. It's going up at the moment because of small satellites, but it's not much more than 100. Compared with 40 million commercial airliner flights, it's a different order of scale. So you need full reusability and higher traffic levels. Higher traffic levels, well, there's only so many satellites you need launching. So you've got to find a new market. And the new market will be activities, commercial activities, that involve the regular transportation of several tons of payload, or many tons of payload per year. Now, the present uses of space, commercial uses, navigation, communication, that sort of thing, they essentially rely on satellites to transmit or process information. And a satellite can process so much information that the high cost of launching a satellite in the first place doesn't make a big difference. You can still make a profit. But things like space manufacture, making things in zero G, solar power satellites, collecting solar power in orbit and beaming it down to the Earth, and above all, space tourism, they all require lots of tons of payload each year to orbit.
Yeah.
So that requires, so with the higher traffic levels, you need safety. Therefore, you design it as much like an airliner as possible. So it's pilots, wings, horizontal takeoff and landing. To use proven technology, you go for 2 stages. So the market-leading design, according to this very straightforward logic, will be piloted wing 2 stages. positive landing.
I guess
Nobody else has come up with that simple logic.
Are you advocating for people to like integrate the learnings from the rocket sector and the airline sector, as you were saying, because there's been that divide? Are you almost like saying we need to like recombine those two areas of expertise?
No, you want to bring back the aviation sector. It's a question of a space plane is an aeroplane with a rocket fitted with a rocket engine. Now, it just so happens, for historical reasons, that since World War II, when the Germans put into operational service the Messerschmitt 163 rocket fighter, they made several hundred of them. Since then, rocket aeroplanes have been limited to a few research aeroplanes, high-speed research, mainly American, Bell X-1, Bell X-2, X-15, that sort of thing. A few prototype rocket fighters, like the Orbital 53, and the Space Shuttle and Buran. There's never been a strong commercial incentive for a long life, economical rocket engine. So as soon as there is a commercial incentive, it shouldn't take very long to develop long life rocket engines.
So I guess if you needed to start this tomorrow, right? Suppose the money landed on your desk, you've got all the money and the time to make this happen. What assets? Yeah. What assets do we have in the UK in terms of like shipyards, in terms of launch complexes, from like historical sources do we have, or can we develop fast to get this off the ground?
We've got them all. We've got them all already. All we have to do is make an airplane, and we've got an aircraft industry. We know how to make airplanes in this country. We've got airports with runways. All we need is the right design, which is, as I said, a two-stage to orbit, piloted, winged, fully reusable launch vehicle.
Right, that's very well established, right? I mean, the US have been doing it for a long time. I think.
No, they haven't. They haven't made a fully reusable. There's never been a fully reusable orbital launch vehicle.
Oh no, but I mean, like for example, I've seen some aircraft. Look at the X-15, for example, right? Dropped from another aircraft. It's not the entire way there yet, but it's that
wouldn't go to orbit. That was only suborbital.
Yeah, but the precedent for suborbital, like two-stage, is already there. It's just a case of pushing that envelope a bit further.
Yeah, that's what it is. You're right. So we've got all the technology and all the facilities you need are available in the UK.
See,
just need to put them together.
Yeah, why do you think the UK struggles so much with that, like pulling it all together for these kind of things?
I don't think we do. The obstacle to what I'm talking about is no more than and is no less than mindset, corporate groupthink.
Yeah, I agree.
If I could find somebody that's got the authority to sign a check and get on with this, either a high net worth individual or a senior executive in the aircraft industry, we'll just do it. The case is overwhelming.
Yeah. And what kind of timescale could you have something up and running if you had all the money?
Well, we could have the full-scale mock-up of this built in about a year, the low-speed prototype in about 3 years, and flying it to space suborbital in about 5 years. If you develop things in parallel, you could have the orbital space plane going in about 7 years. It's very quick.
Yeah, well, this is it. Well, if the money is there, then things do happen fast, and I think SpaceX has been a very clear example of that. They are very cash rich, so it's on the order of years they're able to do suborbital launches and have things laid up. It's just how, like, I guess my biggest issue has been like, how do you transfer that model over here so that there's like that clip, we like get to that speed and get the momentum going.
Well, that's not the problem. The problem is to persuade a big aircraft company to take this seriously. Once they do that, if they sit down and rationally analyze the business case, they'll do it. It's a mental obstacle. I mean, there's 5 reasonable sized aircraft companies in the UK. Any one of them can just do it. They've got the factories, they've got the qualified staff. That's all you need. Well, all you need is the right design. And we can provide that.
Do you not think this?
I'm not saying we got it right. It'll be. I'm quite sure the designs will go a lot of change during development, but the basic concept will stay the same, which is piloted winged 2-stage horizontal takeoff and landing.
I guess my only doubt towards that would be looking at the F-35 and the spiraling cost of development there, and how difficult it's been to prove out even its basic mission profile. Like, I don't know whether there's some either entropy or attrition inside of, let's just say, Western aerospace companies, such that there's so much waste and loss that I don't know whether they would be able to do something like this anymore. Maybe Tempest is an example where they can.
You do it in Skunk Works.
Right, okay.
Experimental workshop. But the F-35, there's only one thing you need to know about the F-35. How many people in the US defense admin, how many project people are in the F-35 project office?
I have no idea. Do you?
There's about 4,000.
Is that a lot?
4,000. It's a hell of a lot. In the project, not designers, not people.
Oh, just in project management. Wow,
people pushing paper around. It's a bureaucracy gone mad.
Yeah, and that's kind of the root of my.
Which is ironical, because Lockheed got going on the first sort of post-war Skunk Works experimental workshop. The idea of an experimental workshop goes back a long time in aviation history. But Lockheed, they built, what was the first airplane they built was the Starfighter, our first generation jet fighter. And they did that quickly and efficiently.
Right, because the Skunk Works, they separated it out from the main company, gave it a budget. The budget was like, this is your budget. You cannot spend any more than this.
Yeah, exactly.
Literally off-site, and they were able to develop it without the pushing and pulling of the bureaucracy of the overarching company, even though they maintained the IP. I think I don't know whether people fully understand what Skunk Works was back then, because people throw around the term in government. I'm not assuming you don't, and it kind of gets lost as to like what the meaning of it is.
Well, I define it as an experimental workshop specializing in rapid prototyping.
Well, I mean, Supernova Labs fits the bill for that. I'm saying the Supernova Labs, that's kind of what we've been trying to develop. So we kind of fit the bill on that front. David, I mean, we're coming up on the hour now, but
time flies.
It does, it really does. But like, I'm really thankful and I appreciate you spending the time with me today, because I've wanted to have this conversation with you for quite a long time, specifically because your experience and knowledge inside of the aerospace industry as it stood and as it stands right now is it's something that like needs to be recorded, and like I'm glad that you've given me the time to do that. Thank you.
Well, it's been my pleasure.
Well, until we speak again, David, I hope you find the investment you need.
Thank you.